Hi, this is AHP, Analytical Hierarchy Process. It's a tool developed for decision making. And here we have a simple calculator which can make the weight allocation to support the decision making. Originally, this is a concept developed by Thomas Sati, and there's plenty of documentation available for this. All kind of tools, but this is my simple version of uh, the decision tool. So here we have it, AHP Decision Lab, as we call it. So we have a simple example here, which is a facility site location, and we have certain criteria for this decision making. We have the cost, labor quality, logistics related parameters, and then we have three alternatives we can choose from. So we have site A in urban context, we have site B suburban location, and site C rural. And we can add, modify the criteria, whatever we have, alternatives, maybe more or less, we can modify these. And then if we're happy with this one, we can start building the analysis. But all of this stuff is something that you can build your own model and modify according to your needs. So over here, the first step is criteria. So everything is evaluated on this type of scale. So we compare the criteria, weighting here, basically now three criteria. All of them are equally important, so we have same weight. But if we say that cost is a bit more important compared to the labor quality, we can give a weight for that one. You can say that cost and logistics, okay, maybe logistics is not that important. We can say about labor quality and logistics, okay, labor quality is more important than logistics. So this is the weighting we have, and now it's calculating them over here. We have the priorities listed here, and if we are not happy with, we can always choose different weightings here. Okay, the next step is to check the alternatives. So we had 1, 2, 3 sites, ABC actually, and in terms of cost, we can start comparing site A against site B in terms of cost. We can say that somewhere here, site A and site C in terms of cost, site B and site C. Okay, and in case we are somehow not logical here, so we will give some inconsistent answers. We will notify that later on in our reporting. And now we can do the same thing for the other criteria as well. So labor quality, we can give some weights here. Logistics, as you can see, these are not measured in terms of some exact units, but this is more like a pairwise comparison of the parameters. And now you can get finally the results, and we have the winner. So now site C is the winner, and we can calculate some consistency to check how much inconsistency basically there would be, and then we have the final report over here showing the all the parameters, basically the evaluation criteria and the weightings, and then our alternatives, and then what are the scores, and giving the idea of the consistency index, which measures the logical consistency of our pairwise comparison, our answers, and it basically measures the deviation of a perfect consistency. So there is some 10% inconsistency in my my response is here in this case. Random index is the average of CI, the consistency index, randomly generated by these reciprocal matrices, and this gives an idea of when we're comparing human judgments against pure pure chance, so how random our responses were. And the CR is the ratio of between CI and RI, and there's some guideline saying that if we are the threshold is around 0.1, and that is expected to be acceptable, and then we are logical enough. So yeah, that's the case over here. We have and this is like a simple tool you can use for your own example. So you can just modify this report and adjust it according to your need, and get at least for a simple example it works quite fine. There's no upper limit on number of criteria alternatives. So I hope you enjoy. Thanks.